Phase noise is a form of noise that's very important in many areas of RF design. It's seen as noise spreading out either side of a signal, and it occurs as a result of small phase perturbations or phase jitter on signals. It's important because it affects circuits and systems, everything from small communications radios to mobile phones, Wi-Fi routers, and right up to large telecommunications systems. Systems with poor phase noise performance may exhibit an inferior bit error rate and not carry data as well, and they can also affect users on adjacent channels. As the phase noise performance of signals is so important, it's necessary to be able to measure it. The easiest way is to use a spectrum analyzer, and there are many different types on the market, from boxed ones to those using PXI chassis and others using USB connections to computers. Making a phase noise measurement essentially entails setting up a scan to measure the noise profile as it spreads out from the carrier. As the noise is dependent upon the bandwidth in which the noise is measured, the accepted standard is to measure it in a 1 Hz bandwidth. It's normally related to the carrier level as well. Also, as the noise varies with increasing offset, the offset must be noted. A typical specification may be something like minus 140 dBc per Hertz at a 10 kHz offset. In other words, 140 decibels down on the carrier at 10 kHz. Fortunately, many spectrum analyzers have special routines built into them to perform measurements such as phase noise. When they do, it's relatively easy to make these measurements. It's a matter of setting up the source under test and setting the analyzer accordingly. However, there are a few points to note. When making phase noise measurements, the analyzer measures the noise sidebands, and these contain both phase noise and general amplitude noise. Normally the amplitude noise is very much less than the phase noise, so the measurement is valid. But make sure there are no other sources of noise around, otherwise the measurement could give erroneous results. Similarly, make sure that the item under test is powered by its correct power supply, or an equivalent one, so that the proper levels are measured. It's also necessary to make sure that the phase noise performance of the analyzer is better than the item under test, typically at least 10 dBs, otherwise the phase noise of the analyzer will affect the readings. Using a spectrum analyzer to measure phase noise is the easiest method and the one that gives the fastest and very accurate results, but it is always best to double check the setup and make sure all the right precautions have been taken.